Hey, good morning. All right, so we're going to take a look at some of the rules that govern those electron configurations we were looking at yesterday. Double check here. 4.2 was our last lesson, so this will be 4.3. We'll take a look again at the four rules that we use to kind of govern some mechanics. And the first rule, easy enough. The first rule is protons equal electrons. We're working with atoms generally. Every once in a while, you might have an ion in there, but we'll cover those a little bit later. All atoms have an equal number of protons and electrons. So as an example here, hydrogen, maybe we did the orbital notation. So O(n), orbital notation, and we'll put 2 electrons there. And hopefully you are recognizing that as a violation. Too many electrons. Too many electrons there. Hydrogen, atomic number 1, only has 1 electron. So this is too many electrons. All right, so that's rule 1. Rule 2 is called the off-ball principle. And off-ball said his rule was that electrons always occupy the orbitals of lowest energy first. So kind of a classic example of a mistake on this one is skipping over the 4s when you go to 3D. So let's take a look at titanium, Ti, and I'm going to look at the electron configuration. So again, make sure you guys are thinking about the orbital notation and the electron configuration, 2 words you got to keep track of. So 1s2, they all start off 1s2 except for hydrogen. 2s2, 2p6. So you're going to be following along your periodic table. We start off with 1s2, then we go to 2s2, over to 2p6, and now down to 3s2. No, we're not to titanium yet. He's way down here. So we're going to cross to 3p, fill that up. And then here's where most people make the mistake, or might make the mistake. They forget that these 2 electrons are in 4s. And a lot of times people just skip right to 3d. And they say, oh, well, 3D is 1, 2, 3, or 4 elements in, but you forgot the 4s. 4s is lower than 3D. So there's our violation. And again, that's a violation of off-ball because 4s is lower than 3D, lower energy than 3D. So you violated off-ball. So it's a classic mistake, violation of off-ball there. All right, next up we have the Pauli exclusion principle. We've already seen this a time or two before. We talked about it yesterday. So again, we saw this yesterday. You can only have two electrons in the same orbital, and they have to have opposite spins, or one has to spin forward, the other one has to spin backwards. I can't do it, but that's what must happen, and that rule is known as the Pauli exclusion principle. So two ways I see this one violated. I'll show both to you. I think I'll be able to do this both in the same. So take a look at the orbital notation of phosphorus. So orbital notation has the arrows. Phosphorus goes to 3p, and then he'd be the third element there. And here is the second mistake that people make. Drives me nuts. This looks like one big orbital, doesn't it? When you don't leave those lines between the orbitals, it looks like one big orbital. So two mistakes on this one. Here. Electrons must have opposite spins. And here, only two electrons per orbital. So again, this one looks like a big, gigantic orbital when you only use one line. And it looks like it's one gigantic orbital with three electrons in it. We can't have that. Those are both violations of the Pauli exclusion principle. I've only got one more rule to go, but I think I'm kind of out of room down here. So I'm going to go ahead and flip the page here for our final rule. And we actually talked about this rule yesterday. It shouldn't be too much new material, just giving this rule a name today. Yesterday we gave it a name too, but that was the informal name. Today, the formal name. So a lot of words here to say a concept that, again, I think for the most part, we've already pretty much got. But electrons with the same spin, so that means up arrow, up arrow, up arrow, or down arrow, down arrow, down arrow, but same spin will occupy empty orbitals of the same energy level before they go back and pair up with opposite spins. So what that means, actually, I think I have to do two different examples here to get this one out. So I'm going to do orbital notation, and that's the arrows for nitrogen. So here's nitrogen, he's in the 2p. He's three elements in, so that means he's going to get three arrows. So our first violation looks like this here. You kind of probably already recognize that. Or another violation, again, take a look at nitrogen again. And this is also a violation of Hund's rule. So those electrons must, first of all, they must occupy orbitals of the same energy. These are all 2p orbitals. So they're all the same energy. So we've got that empty orbital there, and we've got a pair of electrons here. Again, yesterday we called that the bus seat rule. If you're an electron and you get on the bus and there's 2 seats taken and 1 empty seat, you're going to take the empty seat before you partner up with somebody. So there's a violation. And then another violation. I usually go up arrow, up arrow, up arrow first. I'm not sure if that really matters. I've seen some people go down arrow, down arrow, down arrow. And that's fine if you do that as well. But I think it's fine if you do that as well. But you can't go up arrow, down arrow, up arrow. These electrons and these empty orbitals must have the same spin, up, 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 or down, down, down. But you can't have one of them be different. You can't have 2 of them be different. They have to have the same spin in those empty orbitals. So those are the 4 rules. Oops, we have to do this one. Remember, not that it's in any particular order. It's not like rule 4 or anything, just the 4th of the 3 rules we looked at today. And we had Pauli exclusion principle, alpha principle, and always make sure you're counting the correct number of electrons. All right, well, hopefully that helps. And hopefully we get a little bit better with quantum mechanics and how to work with it. And we'll be back with one more small lesson before we finish out this unit. See ya.